Okay, so in this video we're going to take a look at the integration of improper fractions. And just as a reminder, an improper fraction is a fraction which has a polynomial on the top of the fraction which is greater than or equal to the polynomial on the bottom of the fraction. In this example I've called it n. So in order for us to be able to integrate improper fractions, what we need to do is we need to simplify them down. So in this video we're going to give a quick reminder of how to do things like algebraic long division. We're going to simplify using linearity. We're going to look at the natural log method, which was in a previous video. And we're also going to apply some partial fractions, which was also in a previous video. So all we need to do when it comes to improper fractions is we need to use some algebraic trickery in order to simplify them down into proper fractions before we can apply our previous methods. So let's take a look at our first example. Okay, so in our first example we're asked to find the integral, or the antiderivative, of x cubed divided by x squared minus 2 with respect to x. So first off, we can see already that the polynomial on the top of the fraction is greater than the polynomial on the bottom of the fraction in terms of x. So we have x cubed on the top and x squared on the bottom. So we know that we can't integrate this directly. What we can do, however, is apply some long division. So hopefully this is just some revision of your algebra class from long division. So we are dividing x squared minus 2 into our x cubed term. So with algebraic long division, what we're looking to do is find something that we can multiply by this term in order to get us to this term. So since we have an x cubed term here and an x squared term here, it follows that we need to multiply by x. So when we do that, we're left with x cubed minus 2x. Then we subtract here to find what we have remaining. So x cubed minus x cubed is 0. Nothing minus minus 2x is plus 2x. And now we look again. What can we multiply x squared minus 2 by to get to 2x? And we could look at the square root of x in this instance, but that's just going to start becoming more complicated. What we're trying to do here is simplify as much as possible. So we'll just leave this 2x as a remainder. So now what we're left with is the integrand is simplified to, we have our x term, however we have 2x remainder, so we need to still have this divided by the x squared minus 2 term. So plus 2x divided by x squared minus 2. So now we can integrate this directly. So if we take the integral of x, all we need to do is increase the power by 1 and divide by the new power, like we saw in a previous video. And with the 2x divided by x squared minus 2 term, we know from the natural log method, since the derivative of x squared is just 2x, we directly have f of x on the bottom of this fraction and f prime of x on the top of this fraction. So when we take its integral, it's just going to be the natural log of what's on the bottom here. And if that's confusing you, I'd encourage you to watch video 03.4 of my calculus playlist. And as always, since we have an indefinite integral, as in we have no limits, we need a plus c constant of integration. And that's it. So by using algebraic long division, we were able to simplify an improper fraction into something that we can integrate directly. So let's take a look at another example. Okay, so in our second example, we're asked to find the integral, or the antiderivative, of x cubed plus 1 divided by 1 minus x squared with respect to x. And this looks similar to our previous example, however we just need to use some simple algebra tricks in order to simplify it down a bit more. So first off, let's just concentrate on the integrand. So let's call this the integral of f of x with respect to x. And now let's try and simplify our function. So now what we can do here is we can apply linearity to the problem. So what that means is that we can pull out a -1 factor from the bottom of this fraction. So since we have a minus x squared here, this will become a plus, and a +1, this will become a minus. So this leaves us x squared minus 1 on the bottom, and we leave the top as it is for now. And we know as well that 1 divided by -1 is just the same thing as -1. So -1 times. And on the bottom you might notice that we have the difference of squares, which means that this can be simplified into x plus 1 times x minus 1. Now in order for us to simplify this any further, we can try and find a factor on the top of this fraction that's equal to either x plus 1 or x minus 1. And since both of these terms are positive, we'll choose the x plus 1. So let's try that. So what do we need to times x plus 1 by to get to x cubed plus 1? Well, to start off with, we have an x cubed term, so we must need to multiply an x by an x squared term. So x squared. However, that is going to leave us with a plus x squared term. So now, if we add in a minus x, this minus x will multiply with this plus x to go with a minus x squared term to cancel it out. But we still need a plus 1, so we have a plus 1 here, so that needs to be multiplied by a plus 1 as well, so that we have the same on both sides. So before going any further, let's just check that we're right. So we'll check that there. So we have x cubed minus x squared plus x squared minus x plus 1. We can see that the minus x squared will cancel with this one, and the plus x will cancel with the minus x. We have x cubed plus 1. So we're right. Okay, so now that we've confirmed that, we can cancel this x plus 1 with this x plus 1. So now we're left with our function that we've called f of x term is equal to minus x squared minus x plus 1 divided by x minus 1. Okay, so we've simplified it a little bit. Now we have an x squared term on the top and an x to the first power on the bottom. So just like the previous example, if we apply long division, we're dividing into x squared minus x plus 1. So once again, what do we need to multiply this term by in order to get to this term? So since we have an x squared term in here, and x to the first power in here, we clearly need to times by x. So if we do that, we're left with x times x is x squared, minus x times 1 is minus x. And again, if we subtract that, x squared minus x squared is 0, minus x minus minus x is 0, so we're left with 1. So now our f of x term is equal to minus x plus our remainder 1 term. Not forgetting, of course, that it's still divided by x minus 1. So now finally, after using linearity and long division, we have something which we can integrate directly. So let's do that quickly. So the integral of minus x is going to be minus x squared divided by 2. And exactly the same as the previous example, we can directly apply the natural log method again here. So we have minus the natural log of x minus 1. And since we have an indefinite integral, as always, we need our plus constant of integration. And that's it. So now let's look at an even more difficult example. Okay, so in this final example, we're asked to integrate or find the antiderivative of 7x squared plus 16x minus 19 divided by x squared plus 2x minus 3 with respect to x. So if at this point in the video you'd like to pause and try this yourself, please feel free to do so. However, if you don't, I definitely wouldn't blame you. So let's assume you've paused the video and had a go yourself, and now let's go through this together. So first, in order to simplify this, we're going to forget about the integral for now, and we're going to look at simplifying this using some algebra. So the eagle-eyed amongst you might realise that the denominator can be simplified into x plus 3 times x minus 1. And now if we want to simplify this any further, we could attempt to see what you need to times the top by in order to be the same as the bottom. So since we have 7x squared here, we know for a fact that we need a 7 here. So then if we times that out, we have 7 multiplied by our denominator here, so that will give us 7x squared plus 14x's minus 21. So what we're missing from this, which we have here, is we're missing 2x, so we need a plus 2x. And we're missing 2, so plus 2. So now these are equivalent. And what we can do now is we can separate this into 2 separate fractions. So now if we split this up into 2 separate fractions, that gives us 7x plus 3 x minus 1 divided by x plus 3 x minus 1 plus, and we're left with our 2x plus 2 over x plus 3 x minus 1. So the first part of this, very simply, this cancels with this cancels with this, and we're left with 7. However, in order to simplify this any further, we need to use partial fractions in order to split it up. If you don't know what I mean there, I would advise that you check out video 03.5 in the calculus playlist to get a better idea of what I'm about to do next, because I'm going to go over this quite quickly. So if we just focus on this part again, from partial fractions, we know that we can split up one fraction where 2 things are multiplied on the denominator into 2 separate fractions where in this example we just need to calculate the constants a and b. So then if we multiply through by x plus 3 times x minus 1, we're left with x minus 1 plus b x plus 3. And now, like we did in video 03.5, we can set x to be any value because we know that if we can integrate it, it must be continuous. So if we set x equals 1, we're left with 4 is equal to 4b. Therefore b must be equal to 1. And if we set x equals minus 3, we're left with minus 6 plus 2 is minus 4 is equal to a times minus 3 minus 1, so it's minus 4a, and b disappears, so therefore a is also equal to 1. So now we know that this integral is equal to, if we reintroduce the integral, we found that it was 7 plus 1 over x plus 3 plus 1 over x minus 1, because those were our a and b values that we found using partial fractions. And now finally we can integrate this directly. So the integral of 7 with respect to x is just 7x, increase the power by 1, divided by the new power. And we can again apply the natural log method here. So we have the natural log of x plus 3 plus the natural log x minus 1, and as always in our indefinite integrals, because there's no limits, we have our plus constant of integration. So hopefully you found this video useful, and hopefully you can see that it's just using a lot of algebraic trickery in order to simplify it before we apply the same methods as in the previous videos. If anyone has any questions or anything they'd like to see in future videos, please feel free to pop them in the comments box below. And in the next video we're going to introduce a new topic. We're going to begin to look at ordinary differential equations, or ODEs. I'll see you there.